you guys to see. So when I look, it says answer the following questions and circle the corresponding option. So I'm looking, I've got 8, -4, 2, -1. Yeah, it says the first 4 terms of the geometric sequence are shown above. What is the value of R? And so right here is their formula. R is the rate. R is the thing that changes over and over. So what are we multiplying by every time? -1/2. Because the sign is changing, it would have to be a negative R. It did not ask for the next term.
I thought it was saying the next term.
The next term is 1/2. That's not the question. The question was, what's the R value? Everybody okay with that?
It would be R equals.
So if I look at this, can you guys tell me the rest of these? What's my G naught?
Your G is probably not.
Okay, no, that's not what I meant. So do you see that subscript 0? That's not, is how you say that. You know, like how you're used to having y2 minus y1? We don't call it y0, okay? It's called y naught.
Why not?
Yeah. Yeah, not that kind of, not N-O-T. N-A-U-G-H-T. I think I'm spelling that correctly.
Like not.
Like the OG, like the original. Okay?
Or like naughty.
No.
Is that
No.
naughty?
No. That not put an A, I don't think. Pretty sure I put an O. I might have said A. Not that not. Not N-O-T. It's not. I'll look up how to spell it.
It's not naughty, but it's not G. But is it G naught or not G?
I don't know. I don't know how to spell it. Okay. It's not worth my time. 2. Let A sub n be an arithmetic sequence. In my video, did I talk about how to know if you say arithmetic or arithmetic? I probably did. Okay, sweet.
Noun or not noun?
That's correct. That's correct. Arithmetic is an adjective. Arithmetic's a noun. So let A sub n be an arithmetic sequence where A sub 3 is 5, A sub 9 is 14. What is the value of A sub 12? So, I mean, we could go here. We've got something, comma, something, comma. So this is A sub 1, 2, 3 is 5. And then we could say 4, 5, 6, 7, 8, 9 is 14. And you could try to figure out what it is. This is not what I would do. Okay? I know that you guys probably all just copy everything I do as soon as I write on the board.
There's an equation.
There might be an equation. For arithmetic sequences, I don't remember equations.
A-N equals A-K plus D.
A-N equals, okay, A-K, go ahead.
Plus.
Plus
D.
D.
Parentheses. N minus K.
N minus K?
Yes. Parentheses.
Like that?
Yep. I didn't really understand what that meant, but I wrote it down.
Okay. Well, let me show you this then, if I didn't explain it. So for me, what if I moved this back over? And I had A sub n minus A sub k equals D times n minus k? Does that look what familiar to you guys? Probably not. To me, I see y minus y1 equals m times x minus x1. You seen that before? It's point slope formula, except they've just moved the a sub k over.
So is the answer 18? No, it's 18.5. It's got to be something 0.5.
So here's my point. This formula is nice and wonderful, and you can probably remember it and do stuff with it. But for me, I just really kind of need to know what's the slope.
It's 1.
Because it's linear.
It's 1.5.
Thanks, bud. How did you get that?
Because it is. You go above by 1.5.
Bad answer. Bad answer.
9, 14 can be points, right?
That's correct. What were the points?
3, 5, and 9, 14.
That's correct. That's correct. So I think about this as being the third y value. So I think of this as an ordered pair. I got an ordered pair of 3, 5, and I got an ordered pair of 9, 14.
You talked about
And
that
so,
in the video.
did I?
Yeah.
So to find the slope, this is good because like I don't remember what I said and what I hadn't said. To find the slope, I would just plug into the slope formula.
So now you can just do it.
So that would be, and I'm super proud you guys watched the video. 14 minus 5 over 9 minus 3, which would be 9 over 6, which is 1.5, because it just is. Just is.
No, even when we finish, I said because it just is, because it goes up by 1.5.
Yeah, that's what it is doing.
So it would actually take.
And so again, you've got different ways you could do this, but if I know the 9th value and I'm looking for the 12th value, 10, 11, 12, whenever it's that small, I would just do it like this, plus 1.5, plus 1.5, plus 1.5,
Probably.
15.5, 17, 18.5.
I like that.
So we okay with that?
AC
Now-
45 that they-
What you could have done, like, if they asked me to find a sub 300, right? I would not want to keep doing this strategy. This would be a bad strategy.
I have a good.
But if you did need to know that, then that's when you might use this formula. Because you know the common difference is 1.5.
Mm-hmm.
And then you're looking for, this time my n is 300 minus, and you know a k and an a sub k. You just pick one of the ordered pairs, right? Just like in point slope form. You know an ordered pair, you know the slope, and then you're just looking for the y value.
What is N?
No,
couldn't,
it
you,
is,
couldn't you just do?
What's n?
Uh-huh.
N is what I'm looking for,
So
which
300.
value. These are all a sub n's. And so in this particular problem, n is 12. That's correct. But if the one I asked, if it was 300, right, I'm not going to want to keep doing this out to 300. But you can do it if it's relatively a small number or close to what you know.
Or you could just go down to the bottom.
What?
Sounds good.
No, you could like a sub 3 plus 5, you can go.
Here, G sub n is geometric, where G sub 4 is -5, G sub 6 is -45. Which of the following could be R?
So we got, basically what we got is,
So how much have I grown? Remember, we got to think multiplying. How much have I grown to go from -5 to -45?
Negative 30.
you
Negative
actually
40.
decrease.
No, I'm multiplying.
Negative 40.
Think multiplying. Geometric, I'm not thinking adding or subtracting. You're correct, but I'm
You grew 8.
Give me 9.
I did not grow 8. What did I multiply by?
Give me 9.
-5 times 9
I was wrong.
is -45.
Okay, so it's gonna obviously be number 3.
So if I multiplied by 9 to get from G to 4 to G sub 6, what would I have to do to get to G sub 5, which is between them? It would need to be, well, it could be -3, right? What's -5 times -3? And then what's 15 times -3? So -3 works. Would 3 work? What's -5 times 3?
15.
-15. What's -15 times 3?
Negative 45. Oh, so it can be both because it's like both.
So I don't know because I've been given every other term here. So I don't know if the term between them, if we're changing signs every time, or if it's always negative, and I don't have enough information to tell me. So it could be one or the other. I follow what I'm saying when I explain it that way. Let A sub n and G sub n be arithmetic and geometric sequences where A sub 1 equals G sub 1 and they're starting at -1, and A sub 4 equals G sub 4 and they're at 8. What's the value of A sub 5 minus G sub 5?
0.
It's not going to be 0.
What?
It's not going to be 0.
It literally says left.
They're not the same because they're different sequences. So there's no way they're the same. So let's start with the arithmetic sequence. Okay. We start at -1. So this is a sub 2, a sub 3, a sub 4.
There's probably a hole.
There's not a hole. There's not a hole. So because this is arithmetic, I have to have a common difference, right? Something I'm growing by every time. So how much am I increasing by? Well, from -1 to 8, and again, this is just me freelancing, okay? I'm just making this up. I went up 9, which means each time I need to go up by 4.5. Is that right? I don't think that's right. I think I need to go by 3
What?
every time.
There's 3, Jack.
9 divided by 2.
It's not 2.
Because there's 2 empty spots.
Yeah, but you
But
divide by 3.
that's right. You should divide by 3.
You're going up 3.
And so this would be -1 plus 3 is 2, plus 3 is 5, plus 3 is 8. So what would be my a sub 5? What would be next?
11.
Right, so I know a sub 5 is 11. Everybody good with that? Now we need to find g sub 5. So if I look at, this is a sub n. If I look at g sub n, it started at -1. Then we got something, 8. So here this has to be multiplying. So the first thing I see is if this one's negative and this one's positive, I have to be multiplying by something that's negative. Right? So it's going to be negative something, and then negative something, and then negative something. I do not think 3 would work. I think it's going to be 2. So let's try those. What's -1 times -2? 2. Times -2?
-4.
Times -2?
8.
So you see, I just kind of figured out those sequences. You could use those formulas to find them out formally, but I can normally figure it out on my own if it's small enough.
-6.
So then if I multiply by -2, it is -16. So it is 0, just like you guys said, right? No, it's not going to be 0. So again, what was the question? A sub 5 was 11 minus, what is g sub 5? So minus -16 does not equal 5.
-27.
It does not -27.
What?
27.
It's 27. Because this is 11 minus a negative. Minus a negative is the same thing as a plus.
Plus or minus minus is the same as minus.
I hate y'all's rules, but I mean, that don't make any sense to me. But
Minus
Sounds
minus
good.
equals plus. Plus plus equals plus. Plus minus equals minus. Plus minus minus plus equals.
when you have 2 signs in front of a number, that's fine.
Double
Or when you're
equals
multiplying or dividing.
Double equals positive every time.
When you're multiplying or dividing.
1 and 1.
When you're multiplying or dividing. Or when a number has 2 signs in front of it.
Or
Because right here's your minus minus. -5 minus 8. What's -5 minus 8? It's not 14.
3.
It's not 3.
They're -13.
It's -13. So this kind of goes against your minus minus plus. Right? You're not giving me enough information because that's a minus minus. But it's -13. Anyways. Okay, so right here's a geometric sequence being graphed. So did we graph the points of an arithmetic sequence? I don't remember if they did that or not. Arithmetic, that's the problem we found earlier where I told you it's going to look linear. Right? So if I look at the points of an arithmetic sequence, they look like a line. Does this look like a line?
It looks like
No, it's a geometric sequence.
It's a little sussy guy.
It does have an asymptote, a horizontal asymptote, right? Some geometric sequences have them, some don't. It all is just different. They're not vertical asymptotes. Anyways, So what's happening? As the n's or the x's are increasing, what are the y's doing? They are decreasing, and they're getting closer and closer to 0. So the reason I'm telling you all of this is when I see this, because it's getting smaller and smaller and it's approaching a horizontal asymptote, I know that the answer is either B or C. Just from that information. That's what I'm fixing to go over. Do you guys know how I know it's B or C from that information?
Oh, because it's 2/3.
Why does that have to be
The
2/3?
numerator's smaller than the denominator to be an horizontal asymptote.
So as we're getting closer and closer, as the values grow here, right? The n's get bigger and bigger. That means I'm multiplying by 2/3 over and over. It's less than 1. Anytime the r value is less than 1, we're going to be getting closer and closer to some horizontal asymptote.
Because if you're multiplying by 3/2 every time, it would just go over.
It would be growing.
Yeah.
It would be this direction, right? It would be going up. So I know it is B or C. So then the next thing I would do is I would pick a value to plug it in to see which one works. So I really like this point because it's on a crosshair, right? It's 1, 9. So if I plugged 1 in for n, let's just plug 1 in here. What would be 2/3 to the first?
2/3.
And then what's 2/3 times 9?
6.
6.
So this says when n is 1, the y value should be 6. But it should actually be 9. So let's try this one. If I plugged in a 1 here, what's 1 minus 2? Negative 1. What is 2/3 to the negative first?
Negative.
It's not negative 2/3.
It's 0.
It's not 0.
It's ah.
It's not.
It's ah with 2/3.
It's 3/2.
It is 3/2.
It's
Okay?
inverse.
That's correct.
Switch.
If you'll remember, if we have something like 5 to the negative third, we could write this as 1/5 to the third. You guys remember doing those? Negative exponents can be rewritten as positive if I move them to the denominator. Or in this case, we're just going to flip this whole thing, right? 5, this is 5/1, becomes 1/5. So same thing here, 2/3 is going to become 3/2 to the first. Then what's 3/2 times 6?
9.
Yeah. 9. Or you could go 18/2, which is 9. So I know the answer is B,
Oh.
because it gave me 9. Which is what I wanted. That's correct. That's what I was doing. That's why I picked that. Again, are there other ways to do this problem using formulas? Yeah, probably. Okay. But for me, I've never liked formulas for these. I've always been able to logic my way, think my way through the answers. So I don't have any of the formulas memorized. Sorry. If I look at number 1, a table of selected values is given for a function f. Does f appear to be linear, exponential, or neither? And how do we know? So if I look, what do I have here? I have this went up by 2, this went up by 2, right? And so I have a common difference of the numerator. I have equal input intervals. Do you guys remember that we drilled in? So what happens to the outputs over those equal input intervals? Well, from 15 to 8.5, we went down by 6.5? And then what about from 8.5 to 2? Down by? Okay, so that seems kind of linear, right? And remember, we were skipping 1 over here. So what would it be like? What if I went from -5, 15 to -4? What would be the value there? So if I went from it would be negative 3.25 every time, which would put me at 11.75. I agree. And so, anyways, right here, look what I'm going. I went up 3. So what would I need to go down here? I would need to do minus 3.25 3 times. Are you following my logic here? Which means I need to go down. You okay with that? So did that work? Is this down 9.75?
Yeah.
Well, if I went down 2, that would put me at 0, right? And that would leave me with negative 7.75 to go. Following how I'm breaking that apart? In my head, it's hard to do 2 minus 9.75. That breaks my brain. So I did, yes, that's what you do. But it's just, again, I don't want to do that in my head. So I went from 2 to 0. That means I went down 2. So get rid of going down 2 here. This becomes minus 7.75. So from 0, I go down 7.75 to get me 2. It doesn't matter. The moral of the story is it worked. You don't have to know how to do my mental math. And so because it worked, because it's linear, how do I know it's linear? Because I have
First comment.
Denominator.
over equal input intervals, I have constant differences, or I have a common difference. It's linear. Write an equation of a linear function that goes through these points.
Y equals.
So what do I need to know for a linear function? I need to know the slope. How can I find the slope given 2 points?
Different. Y2 minus y1 over x2 minus x.
And they're going to want to see that, right? Again, this is one of the things you're going to have to write on your free response questions. You have to write this. So let's get in the habit of doing that. That would be 56 over 2, which is 23. So the slope is 23.
56.
63 minus 7 is 56, right? Did I do that wrong?
Where did you get 63?
Would it be 1 minus 3? Instead of 3 minus 1.
Oh, okay.
Yeah.
Okay, I see.
Yeah. Thanks. That was not the eraser. That was not erasing what I wanted to erase. There we go.
3 minus 7.
Should be 1 minus 3, which should put me at negative 23. Thank you.
56.
So now y minus y1 equals m times x minus x1. And there is an equation of a line. It didn't ask for it to be in slope-intercept form, so I'm just going to use point-slope form. Is it okay with point-slope form? We kind of talked about it earlier. Y minus y1 equals m times x minus x1.
Wait, that's slope?
It's called point-slope form. This was the slope.
Y2 minus y1 over x minus x1.
That's the slope formula. That's not point-slope form.
What's point slope?
That's the thing I wrote earlier up here. Y minus y1 equals m times x minus x1.
Yeah, we don't like that one.
Yeah,
We just like the
y
y
equals mx.
Yeah, but I like it this time because what do I know? I know the slope and I know a point. I know a slope and a point. A point and a slope. Point, slope form.
But it's so ugly.
Yeah, I'm not having to graph it. Does it say use point slope form to do? No. Just give me an equation of a function. I've got an equation of a linear function. Right? It says equal to. That's an equation. All I need. Could I go ahead and put this in slope-intercept form? Yes. Am I wasting time by doing that? Yes. There was no need to do that. Didn't ask it of me.
It would look better.
Go right ahead. Just,
No.
you're right. I could have done it in the time I spent arguing with you. I could have had this in slope-intercept form. Next, same 2 points, but this time it's not a line. This time it's exponential, which means it's geometric. So, you guys remember that big, ugly, G sub n. I'm trying to see if I can find the formula. Did we write it on 12 or 13? Did I ever write the equation down for you guys to copy? No. Okay, we just saw it on.
To the end.
We just saw it on number 1 on that problems that we just did, where it says G sub n equals G sub naught times R raised to the n.
The hemoglobin under.
What?
So I need to find that formula. If I haven't shown you guys. Because this is not going to make any sense to you, what I'm fixing to do. And I'm just winging it. I'm going to divide the y values. 63 over 7 means I would get 9. So to get from this point to this point, I would multiply the y's by 1/9, right? 63 times 1/9 is 7, which means if I needed to find the point between them, I would multiply by 1/3. Because 1/3 times 1/3 is 1/9.
Everybody needs to appreciate the number 1.
Please don't, I don't know what we're doing. So, to find the point that's in between, it would be 2, and then 63 times 1/3 would be 21. So again, there's got to be a better way to do this than what I'm showing you. But what I've just figured out is I need to multiply by 1/3 every time. 1/3, 1/3, 1/3, 1/3, which means my R value is 1/3.
How you know it's 1/3?
That's what I just tried to explain, and then I got told how important 1 was in the middle of it. Here's how I knew it was 1/3. There's a better way. I'll look up the formula and show you tomorrow. Okay? But I told you guys I don't remember formulas for these. I'm just able to figure it out.
He's logical.
Thank you. So to go from 63 to 7 in the y values. And notice I skipped the ordered pair 2. Like you see how it's like a sequence of numbers? 163, 2 something, 3, 7. Well, just to figure out what I have to do to go from 63 to 7, I divided those. And I got 9. So that means 63 times 1/9 is 7. So then I said, well, how did I get to 1/9? I had to multiply something times something to get to 1/9. So essentially I took a square root. And it was 1/3. What's the square root of 9? What times what is 9? So what times what is 1/9 is 1/3.
That's the one,
So
one in the middle.
63 times 1/3 gave me, and 21 times 1/3 gives me, so I figured out that I'm multiplying by 1/3 every time, which was the R. And so then for me to find the other term, this is the G naught term, the first term. Well, if I multiplied by 1/3 and multiplied by 1/3, what if I went the other direction? Times 3, times 3, I can multiply this by 3. So it had to start with 189 for the original term. So this would be 189 times 1/3 to the n is my formula.
To the end.
Again, is that the best way to do this? No. And I'm sorry. My apologies. It's me that hates memorizing formulas that likes to think through how I got there. Because they kind of go hand in hand. Geometric sequences were where we multiplied to find the next value. And then if you'll look here at the far right, sorry, I don't have my iPad turned on where it's mirroring. If you look at the far right on page 15, where it shows h of x equals 2 raised to the x, you see that is an exponential function. And to find the next x value over, we're multiplying by a power of 2. Right? So if you look at it algebraically, you see here when it was 2 times x, and x was to the first power, those graphs are linear. When it was x raised to the second power, that's a quadratic, which looks like a parabola. Now then, people get these confused when we first start them. But if you notice the difference, for an exponential function, the x is in the exponent. Remind me before you leave, I can show your test grade. We just looked at them. Does everybody see how this is different than this, right? X squared is different than 2 to the x, like mechanically. People just think because it has an exponent, then it's going to be a quadratic. But now then the variable x is in the exponent. And you kind of see what that graph looks like. Exponential functions are some of the most important functions in the real world. They appear in many places, including population growth, money in interest and in debt, radioactive decay, spread of disease, etc. In addition, the SAT, which you guys are not going to take, the ACT will include several questions that require understanding of exponential functions. So it says an exponential function has a general form of f of x equals a times b to the x. The b value must be greater than 0. So we're not going to have a negative b value. A and b are constants. A cannot be 0. B cannot be 1. And so why are they saying this? What would happen if a was 0?
It'd be a straight line.
Yeah, if this was 0, what's 0 times b to the x? It's 0, yeah. And so then you would just have f of x equals 0, which is a horizontal line, right, if that was 0. What would happen if b was 1? What's 1 to the x power? So what's 1 to the second? 1 to the third? 1 to the fourth? It's not growing exponentially, right? If it's 1, it's going to stay the same value. It would just be a, because this would be 1 times a, which is a. So that's why those are thrown in. So I don't know what's supposed to go in these. I'm going to give you my best guess, okay? And then we'll look it up. I think A represents the initial amount, is the word I would use there. And B represents the, so when we did arithmetic sequences, how much we were adding by every time, that is called the common difference, right? If I added by 3. This one's multiplying. So geometric sequence, the thing that we multiply by over and over and over is called the common difference. Oh, what's it called? It's the something rate. Constant rate? I don't remember. That's what I'm going with. It's the thing that's being multiplied over and over and over, right? That's what the B value is. I'm pretty sure it's called constant rate. All right, so looking here, if the A value is positive, right? If the A value is greater than 0, and if the B value is bigger than 1, right? So if this is anything bigger than 1, what's going to happen when we raise something bigger than 1 to the x power? Like, what if it was 2? What's 2 to the second? 4. 2 to the third? 8. 2 to the fourth? 16. If this is bigger than 1, this whole thing is going to grow. That's why it's an exponential growth problem. Right? From left to right, this graph is going up. Now, the exponential decay is the other direction. Here, A is still positive, but now the b value is less than 1, but bigger than 0. So pretend like it's a half or a third or a fourth. If we have 1/2 to the second power, that's a fourth. 1/2 to the third power is an eighth. That's going to make the values get smaller and smaller and smaller, right? As the x's grow, here the y's are getting closer and closer to 0. Right? I maybe should have put that in limit notation, right? The limit as x approaches infinity of f of x is 0. So you can see this, what is the x-axis acting as?
Horizontal axis.
It's like a horizontal asymptote. The only difference is with rational functions, remember it tended towards the horizontal asymptote in both directions. That's not true with exponential. It only tends to the horizontal asymptote in one direction. So for here, when the x's get bigger, we're going closer to the horizontal asymptote. What happens when the x's get smaller? What's the y's going towards? Infinity. And then here is vice versa. As the x's get smaller, what are the y's heading towards?
0.
That horizontal asymptote. As the x's get bigger, now we're going towards infinity. So they only tend towards the horizontal asymptote in one direction. Exponential functions are always increasing or always decreasing. They never switch from one to the other. So there's never a local extrema, right? No local max or local min, because it's always increasing or always decreasing. Exponential functions are always concave up or concave down. They never switch concavity. So that's some of the reasons why these are so important in calculus, because they're consistent in that way. And then we've already talked about the end behavior, right? This is explaining what I already did in limit notation. It just looks uglier because we've got limit as x approaches either positive or negative of a, b, the x. That looks awful, but I promise that's saying exactly what I said earlier about limits. Okay? Take my word for it. So now we're going to practice doing some of these. It shouldn't take very long. So right here, left limit. So this is saying as we go left. So the limit as x tends towards negative infinity of, I'm just going to name it f of x, is, what's happening? As the x's get smaller, the y's go to 0. And then on the right side, the limit as x approaches infinity of f of x. So as the x's get bigger, the y's go towards infinity. Right here, what about happens when I go left? The limit as x approaches negative infinity of f of x is, what are the y's heading towards? Negative infinity. And then here, the limit as x approaches infinity as I go right.
0.
It's so nice to have my Apple Pencil back. I'm so excited. I can write so much faster. Everybody good with that? All right, now what's the deal here? What's the deal, Bill?
You got to draw. Oh, wait.
We just have the equation. We don't have a graph. So what's going to be the most determining factor here? This rate, right? The common ratio, the constant rate, whatever it's called. It's 2/3. So what's going to be happening?
It's going to be shrinking.
Yeah, as the x's get bigger and bigger, because this is less than 1, it's going to be getting closer and closer to 0, right? Or is it 0? Yeah, it's 0. So we would say, right here, the limit as x approaches infinity of f of x is getting closer and closer to 0. Another question is, does it look like this, or does it look like this?
The top one,
How do you know?
because there's no negative.
That's correct. If the A value here is positive, it's going to be up top. A way that you can check that very quickly is plug in 0 for x. What happens when x is 0? What's 2/3 to the 0 power?
2/3.
No. 1. Anything to the 0 power is 1. Well, almost anything. It's 1. And then 1 times 5 is 5. So if I plug in 0 for x, the y value should be 5, which lets me know I'm up 5. So the A value, I don't want to say that. Let's don't say that. That's not always true. So then I could say here the limit as x approaches negative infinity of f of x is infinity. Let's look at A. Is that concave up or concave down?
Concave up.
I agree. Is everybody okay with that? It would hold water if, what kind of? All right. Kind of would hold water.
If you tilted it, it would.
Yeah, if you tilted. Yeah. If you tilt, well, whatever. We'll just go with it. And then, is it increasing or decreasing?
It's decreasing.
It is decreasing. From left to right, the y's are getting lower. So that's concave up and decreasing.
It's decreasing at an increasing rate.
Oh, let's don't go there. B.
Concave down.
B is concave down. Is it increasing or decreasing? It's also decreasing. Y's are going down.
It is decreasing at a decreasing rate.
Okay. C. 3 times 4 to the x.
Concave up.
It is going to be concave up. How did you figure that out? You just picked one of them?
No. And it is increasing.
So we know the y-intercept here should be at 3. And because this b value is bigger than 1, it's going to be growing like this. So it is going to be concave up, and it's going to be increasing.
At an increasing rate.
Yes, thank you for all of those. You didn't miss any of them.
I can see those tangent lines in my head. Yes, I can.
Okay, you guys, let's go back to our table of values. How can we tell if something is linear from a table?
Same X difference.
If I have
Y difference.
constant
Differences.
intervals of the x values produce a common first difference.
Yeah.
So right here, the x's are going up by 5, by 5, by 5. So do I have a constant interval?
Yes.
So now we're going to see what's happening with the y's. From 3 to 5, up 2. From 5 to 9, up 4. From 9 to 17, up 8. From 17 to 33, up 16. So do I have a common first difference? No, so it's not linear.
It's doubling.
Thank you.
So is it?
What about from 2 to 4? I got to check the second difference for quadratic, right? So from 2 to 4 is up 2. From 4 to 8 is up 4. From 8 to 16 is up 8. So is it quadratic? No. You could check again if it's cubic, but is cubic going to work?
No.
No. So this one might be exponential. So how can we check if it is exponential?
I'm not sure.
Okay, here's how you can check. Once you have found the first difference, what if I divided 4 by 2? What would that give me?
You found that fraction.
What if I divided 8 by 4? What would that give me? 16 divided by 8. So you see how we're introducing division into this. So if I can divide the first differences, or the second differences, or the third differences, and I get a same constant rate, then it's exponential. Okay? That's the way you can check very quickly. Okay, so this is going to be a little bit awkward here. I'll put some stuff on the board here. We'll see if we can make it work. So we're on page 17. Do you guys see that? So you see where it says graph A? It asks you for the equation. We'll do the equation last. Okay? We'll do the equation last. Let's start with, is A increasing or decreasing? Increasing. Concave up or concave down? Is everybody okay with this? So can you guys answer all of these for increasing, decreasing, concave up, concave down? Is everybody finished with B?
Of what? Yes. What are y'all looking at?
Now you guys got all those done?
Oh. No. I have them down on the paper, just differently.
You graphed them already?
No, I found the graphs and I was writing it under the graphs.
Okay, you guys can find this on page 19 if you want to look there. On 19, we're looking at the first 6 and we're trying to match the equation to the graph. So when I look at graph A, anybody have any ideas? I don't want to just ruin it. Which ones is it not?
It's probably the
It's not the 1/2 to the x. It's not the 1/4 to the x. Okay, very good.
it's probably like the 1/5. If that's
That one is not the negative 2 to the x. So here would be my process I would go through. First, I would identify what happens when x is 0. So if I plug in 0 for x, what should be the y value? 1. Okay, that's going to actually work for every one of these this time, right? Because if you'll notice, there is no a value on any of these. It's only the b raised to the x. So the a value is what will adjust the y-intercept. So that one didn't work. So let's look here. If I plugged in 1 for x, the y value should be 2. So what do I raise to the first power and get 2 as an answer? The money symbol, right? 2 to the x. Try the next point just to see. What if I plugged in 2? What should I get? 4. So what is 2 to the second?
2 times 4.
It's not 2 times 4. 2 to the second is 4. So when I plugged in 2, I get 4.
Right.
If I plug in 3, I should get 8. So the money symbol works for A. Okay? Now that you guys kind of see my process, try B. See if you can figure out which one is B. Have you got it? Which one's B? 1/4. How'd you get 1/4? Did you plug in 1 and see that was at a fourth? No, that wouldn't be very good, would it? How'd you figure it out? -1. Did you plug in -1?
No.
You didn't do that either? How'd you figure it out? You just saw it? You just knew it? Okay.
I think it's.
Is that not that? Is that
It is 1/4 to the x. And the way that I would do it is I would plug in -1 for me. If you plug in 1, it is kind of hard to tell exactly where this is at. But if I plug in -1, it very clearly hits at 4. So what happens when I have a negative exponent? We talked about this yesterday, right? Negative exponent will flip the b value. So if I put -1 here, 1/4 to the negative first is the same thing as 4 to the first. So you should get 4 when you plug in -1, which worked here. And then if you plug in -2, you should get 16. I might. All right, I don't know. I really don't have any other point to go on other than that one. So that one is 1/4.
I had to guess. That's the one I would guess.
On which one?
That one.
Oh.
I would guess that
Well, don't guess. I showed you ways to figure it
one.
out.
I know how to do it now.
So C is 1/2.
Because at -1 it's 2.
it flips?
Okay.
Because at 1 you can tell it's 1/2.
Oh, brother. Yeah, you know without a shadow of a doubt at 1 it's a half.
Oh,
It's not
at
even
2
close.
it's 1/4. At 2 it's 1/4.
Yeah, easily. 2 is 1/4. 3 is 1/8. 4 is 1/16. There's no question. 5 is 1/32. No, that's not a great way to do that. Right?
And it is,
If you're going to do it, a half is the best one to do it with. But
it's concave up and it's decreasing and an increasing.
okay, thank you again for all your.
Are you sure it's not decreasing or decreasing?
No, because there's not a negative exponent in front, or a negative value at the front.
I do not know what's happening to my iPad. This is not going to end well.
I think you should throw it into traffic.
Okay, what about D?
The act sign.
The at symbol?
Oh, you're gonna like this. It's decreasing at a decreasing
It's
rate.
-2, yeah. I agree.
So you know how I told you guys that the A value was 1 on all of these? I kind of lied. Because on at symbol, the A value is not 1. It's -1. Because what would happen if you plugged in 2 to this equation? What's -2 to the second? 4. Should it be 4 if I plug in 2?
-4.
How's it -4?
-2 times 2 is 4.
So remember on your calculators, I may not have done it as much with you guys.
You gotta put parentheses.
You have to put parentheses before you do an exponent if there's a negative thing that you're raising to a power. Because the only thing this exponent goes with is the number, if it's not in parentheses. So because of this, this is like -1 times 2 to the x. Right? Because that negative is not in parentheses. Right? This is different than this.
Oh, so it's negative. It's gonna be negative x.
Here, it's whatever you raise to the power, you've got to multiply by -1. So it's always going to be negative. Here, this is going to alternate. Right?
It's gonna be like doom.
Yeah, it's not going to look like any of these graphs. So that's why we said, if you remember the rules, we said that the B value had to be greater than 0. Right? B value can't be negative because then it becomes not.
That is one negative Nelly right there. It's concave down, decreasing at a decreasing rate.
Thanks. Okay, so I've got that one eliminated. So now we look at E and F. Those are pretty different. Which one do you want to do first? E or F?
E.
Because I have a good feeling.
You gonna do E first? Okay. E kind of scares me.
It's 1/3.
Why?
I don't know. I think I could do F pretty easy right here if I look.
Yeah, but you can look at it and tell it it's gonna be 1/3.
It's 1/3. There's no 1/3. Equal to symbol should be matching with wherever we had dollar symbol.
That one has to be the same as 1/3.
Okay. Can we do F? Which one is F?
F is,
Like,
F is the exclamation point. Right, that one's the easier one to identify. Is everybody okay with that without me doing a lot of talking? So then what's the deal with the hashtag?
What? There's a little thing. I think it's the same as a fraction.
This?
Yes.
It's a negative. This is 3 raised to the -x.
Which is the same as a fraction.
What do you mean it's the same as a
Because
fraction?
if you go negative, it's a fraction.
If you go negative exponent, I didn't say it was a fraction. I said you flip the B value, flip the number,
So if you flip a regular number, then there's a
and
fraction.
it become a fraction. I'm in. I'm okay. So because this is to raise to the -x, if I plugged in a 1 here, what would be 3 to the -1st? Well, 3 to the -1st is the same thing as 1/3 to the 1st, which would mean I would be at 1/3. Right? Is that like this at 1/3? Maybe. Let's go the other way though. What if I plugged in -1? Our expert here says that is at 1/3. We can feel confident.
it would be
3 raised to the -1st. Well, what's the -1st?
3 to the first.
3 to the 1st, which is,
1/3.
it's not 1/3. 3 to the 1st is 3 in all walks of life. And so if I plugged in -1 for x, the y value was 3. So this is 3 to the -x. Can you guys think of another way we could write an equation for this that would still be the same thing? Instead of writing 3 to the -x?
1/3 to the x. Yeah.
See,
So these are the same thing,
I said earlier.
right? 1/3 to the x and 3 to the -x are the exact same thing. If you graph them, they graph exactly on top of each other, which is kind of unique. You might think that this is. I don't want to go there. Let's just say this. Let's say that quadratics are some of the most tricky because there are multiple correct equations for a graph. Right? There are multiple ways you could write it that look the exact same way. Because think about all those transformations. We've not done any transformations yet, right? We could shift left and right. We can shift up and down. We can stretch, which is kind of like the A value, right? Stretch, compress, reflect. All of those things still are in play here. So when you look at question 2, it says, how can you tell from an equation whether the function is exponential growth or exponential decay?
Decay will have a negative Nelly on it. No, it'll have a fraction.
Okay? You're going to have to say more than that, though. Because E is what kind of problem?
It'll have a negative exponent or a fraction.
So if I have a negative exponent with a number bigger than 1,
Yes.
or if you have a number less than 1 with a positive exponent. Right, those would be decay. You guys follow? I know I didn't write any of that down. It's a lot to write down. But we can see here, this was a number bigger than 1 with a negative exponent, and that resulted in decay. And then on this one, what did we match it with? We matched this one with 1/2 x. Here we had a number less than 1 with a positive exponent. That also resulted in decay.
A negative exponent's like a knot. It's like, it's not this.
Okay. Thank you, computer science. If you look at 3, go back so you guys can see this. Oh, we found one extra card that I need to match. It's 2 to the negative x.
Oh, what
Where should 2 to the negative x go?
C.
Should match with the star, which was C. Okay? So then why is it possible for one graph representing 2 different equations?
Because it's the same they're the same when you graph them.
We're saying it's
Right, because negative exponents can work as reciprocals, right? That's a good enough explanation. To me, I don't really like that question very much. Right? I don't like the why there. But we kind of understand that it's a possibility. Three says, okay, and so now then we've got the same thing again, but we've got uglier graphs this time. Okay, so I'll put them on the board again. Can you guys look at the equations? Or do I need to take a picture of them? What was easiest for you guys? Yes, I agree. I think it's easier on your screen or on your paper than me putting it on my screen. I'll put them up there. We're looking at the 9 that we did not use earlier. So I've only got 6 graphs and I've got 9 cards.
maybe we're gonna have 3 that are the same.
Maybe. So when you look at G, what are some things you're looking for with G? Like for me, I would just try to match them all with 1 first, and then I would go back and see what's left. Anybody see they feel good about?
3, 4, 4, 8. I think this is exponential.
It's probably 2.
Yeah, every one of these is exponential. That's probably a good guess. You stuck on G? Nobody's got any good ideas for G?
It's probably like it doubles it.
I didn't hear what you said.
It's the infinity.
Yeah, that's the one.
Infinity.
You like the infinity symbol?
Yeah.
Okay. Here's why I don't. What's the rate? What's the constant rate here? Less than 1. So what should be happening?
Oh,
This one should be decaying.
it's pi.
Yeah, it's
Pi. 1/2 times 2 to the x.
Yeah,
Okay, is this one exponential growth?
Yes.
But then this is changing the y-intercept, right? So let's just think, if I plug in 0, what is 2 to the 0? What's 2 to the 0? 1. What's 1 times a half? So could that be 1/2 at 0? If I plug in 1, 2 to the first is 2. 2 times a half is 1. So if I plugged in 1, I get out 1. If I plugged in 2, 2 to the second is 4. 4 times a half is 2. So if I plug in 2, I should get 2.
3.
That's looking good. So I'll agree. I like G being pi.
H being. Oh, there's a. Yeah, there's a Scooby asymptote.
Yeah, so what's happening with H?
There's been a change.
Yeah, so the main thing is the horizontal asymptote has changed.
It's not at 0.
It's not at 0. It's
Okay, so I know which one this one is.
It's the and sign.
the and sign. Why?
Because there's a
Because
plus
when
2
it's at
after the
0, it
exponent.
makes it.
So what's plus 2's do with our transformations? They should shift the graph up 2. So it would move the horizontal asymptote up 2. So I like it. We could check some of the other points if we wanted to. Right, plug in 0. What's 3 to the 0?
3
3 to the 0.
is 1.
1 plus 2.
2.
3. So if I plug in 0, I get 3. Boy, mental math is not just thing. If I plugged in 1 for x, 3 to the first is 3. 3 plus 2 is 5. So if I plug in 1, I should get 5. So I got 2 points there. I feel pretty good about that. Okay? So we said H was the and sign. What about I?
The copyright symbol.
Copyright symbol? I don't like that one on that one.
Probably the little arrow going up thing.
Yeah,
What?
that's the one I like there.
The exponent symbol.
Because that one is shifted down 1, right? The horizontal asymptote is down 1. Okay, so we've used this one, we've used this one, we've used this one. All right, what about J?
J did it.
It's the infinity.
Yes, it is the infinity.
Okay, infinity, I like it for when I plug in 0. If I plug in 1, I like it. I like it. I think it is the infinity. I'm in.
Good job, Chris. Oh,
I don't know what this symbol is.
Which one?
It's the I think it's
That's the omega.
Well, it looks kind of like an S.
Yeah.
That in calculus is called an integral. I don't know. They're also on the plates at Waffle House if you go there. We used to always say, look at all these integrals on our Waffle House plate when we were nerds in college. But next time you go to Waffle House, check it out. Which I heard is coming to Rainsville. Did you guys see that post? It's coming to Rainsville. Waffle House.
What is that?
The one in Fort Payne's having to close because they're having, I think they're going to have to expand the highway some when they make the new traffic circles. Oh, gosh. That's gonna be disaster. Yeah, roundabouts. Yeah,
They're
the
putting one of those in.
They're
Fort
putting
Payne.
Two.
roundabouts in Fort Payne.
two on each side of the interstate. You know where it backs up, which y'all probably don't drive when it's really backed up at like 3 or 4.
Oh, yeah.
It's gonna be. They're gonna have roundabouts on each side of the overpass bridge right there in Fort Payne.
Dude, I'm gonna just drive on that roundabout all day.
And so I think in part of all that expanding, they're going to have to expand to that parking lot. And I think that whole hotel and
Fort Payne's pretty
Waffle
much
House,
like
that's been a rumor for a while. I've not heard that officially, but
So you think the one in Fort Payne?
I'm going to see. I think we might can get about 3 lessons done today, which should be good.
And then we won't have another one until Friday.
Well, I don't know. We'll see. I'm hoping that I can get far enough ahead in case volleyball is playing on the 29th and 30th that it's okay if I just lose those days. No, I'm not going to do those quizzes. I realize it says we have a quiz. We're not to it yet. We're a little behind. But I'm probably even going to do those quizzes. I'm probably just going to axe them. All right, so we were identifying these 6 graphs. We got 5 of them done. So we're looking at L.
L,
X log functions code. Okay, so this one could be.
I see a 3.
You see a 3. On which one?
For L. Oh, I meant like it crosses a 3.
Okay, yeah, so we got y-intercept at 3.
So the little,
So which one of these are you drawn to?
I thought the plus whatever was the y
Which one?
It's wrong. Whatever I was thinking is wrong.
Okay.
Maybe the horseshoe.
Okay. Does anybody know what that one is? I think it's omega. Does somebody else agree? Okay.
I agree. Sounds right.
Okay, sounds good. So let's plug in some values here and see if omega works. If I plug in 0, what should I get out? 3. So if you plug in 0 here, what is 0 plus 1? 1. What is 3 to the first?
3.
So that worked with 0. Now let's try to plug in 1. If you plug in 1, looks like you should get 9. 1 plus 1 is 2. 3 to the second is 9. So that's looking good. And plug in -1. We should get 1. Oh my gosh. What's -1 plus 1? 0. What's 3 to the 0?
Oh, I thought. Oh, never mind.
1. So this one here is omega. So we've got that one used now. So all of these map to 1, but we've got 3 left over. And so remember we learned yesterday that sometimes they can be written different ways.
I like that. Simple.
So when I look at 2 raised to the x minus 1, is there any of those that draw your attention immediately that you think that might be it?
For which one?
For the copyright one. So like I'm looking at the other equations, right? So when I look, does copyright look similar to any of the other ones?
It's
3x to the
either,
1.
I'm looking at J or K.
Oh, so you're looking at graphs.
Oh, my fault. Yeah, for the
It looks kind of
for your
exactly.
copyright. Cause if we plug in,
Kind of like G.
Wait, are we supposed to be looking at the graphs or the other?
I meant the other equations, but y'all keep calling out grass. So
No, it kind of
No,
looks
not
like
that,
the
not
same
that.
one as the circle with the legs.
Omega.
Yeah,
yeah.
I mean, I can see the similar to that.
okay, so what we're fixing to go over here is very important. Like, to me, this will be the most important thing we've done yet. Like, this has been good, us figuring out how to kind of figure out what the graph looks like. My thing with exponentials, I do not think the graphs are as important as this that we're fixing to show you right now. So,
I think it's the same as pi.
okay. What makes you think it's the same as pi?
Because the negative fraction or the negative exponent turns 2 into a fraction. And there's a 1/2 right there.
Okay. So let me show you guys this. Again, what I think is the most important thing we've done yet. Let's say I had something like this, 3 to the 7th power. I can rewrite this. 3 to the 7th doesn't have to stay as 3 to the 7th. Do you guys agree that 7 is the same thing as 5 plus 2?
Yes.
Of course.
So 3 to the 7th is the same thing as 3 to the 5th plus 2. 3 to the 5 plus 2. Now, how did I get to this point?
You distributed it as 7.
I did not distribute.
You expanded the 7.
Oh, gosh.
You summarized the 7.
Okay,
Broke apart the 7.
let's go here. Let's go here. Let's go here. Let's go here. What is x to the 2nd times x to the 5th?
Oh.
And how did you go from x to the 2nd times x to the 5th to x to the 7th?
When you multiply exponents.
When you multiply powers with the same base, you keep the base the same and you add the exponents. So I'm basically, you see how I worked from here to here, here to here?
So
Now let's go the other direction. If I had 3 to the 7th, which could be written as 3 raised to the 5 plus 2, this could have been written as...
1 plus 1.
No. 3 to the 5th times 3 to the 2nd.
That's what you.
I did it in the opposite direction. Do you follow that?
Would that be distributing?
No, I don't even know what it's called. Rewriting in an equivalent form?
That's
I-
unsimplified.
Kind of. So you can see this is the order you're used to working. What's in blue. You've been doing that for a while. Well, now we're going to kind of do what's in red. So when I look at copyright has already done this step. You see, we're here. We're at 3 to the 5 plus 2. This time it's 2 to the x minus 1. You see how I'm kind of on this step? So now how could I simplify it? What would 2 to the x minus 1 look like if I broke it down another step?
2x
2 to the x times
2
2
minus 1.
to the negative first. And if you need to think about it, what would happen if I multiply 2 to the x times 2 to the negative first? These are powers with the same base, right? We would keep the base the same and we would add the exponents. What's x plus negative 1? X minus 1. Right? So I kind of am undoing that. Now, do we like negative exponents? Not really. So I could fix that 2 to the negative first.
And you could make it 1/2.
1/2 to the positive first, which would just be 1/2 times 2 to the x is left over, which matches with pi.
Ice in my veins.
You see how they're the same in different forms.
Okay, so they're the same, so we need to find one that is the exact same.
Well, so we know G was pi, so G is also copyright. So when did I do that? When my exponent had something being added or subtracted. So when I look at my other two, did they have exponents being added or subtracted? The approximately symbol and the sigma
Wait, where's
symbol.
sigma?
Where's
Bottom, right?
Bottom. Oh, sigma.
What
It looks like a sideways M to
Can
me.
you text that? Like, I'm gonna start texting that. Is that like an emoji or something?
You probably can. It's probably in special characters. If you change your keyboard
Let's go.
to not
I've
be,
never seen that sideways
I'm
M.
gonna start texting
I have.
people that.
it's a summation. So if you do sequences and series math
I
and
saw it
like
on the side of a frat house.
it's a Greek letter. Anyways.
Yeah, I've never seen it before.
So if I had something like this,
Sigma something.
this is called series of numbers. So it's the summation from. Well, I need to use
N
n.
equals 1.
My sister
The
told me-
summation from n equals 1 to 5 of n. This means I plug in 1 for n, and then I'm going to go all the way up to 5. So then I would plug 2 in for n, 3 in for n, 4 in for n, 5 in for n. So this says this. They're the same thing.
1
That's right.
So 11.
So you can make this expression more difficult. You can make the ending value anything you want. You can make the starting value anything you want.
Is-
15 is good. After
So-
My sister tried to get me to help her the other night to divide by sigma, and I told her I didn't know what she was talking about.
Anyways, these two do not have anything being added or subtracted. What's happening in the exponents here?
there be the 1.
So I got things being multiplied in the exponent. So help me remember our rules. How did I get multiplying in the exponent?
You would.
Does anybody remember from your exponent rules from 8th grade? Because that's what this was. This is the 8th grade exponent rule, right? That we're bringing back. So how did I get multiplying in an exponent?
If they're raised times the 2 times.
When I have a power raised to a power, we multiply those terms. So for instance, if you had x to the 5th to the 4th, okay?
Oh, yeah.
Power raised to a power. We can simplify this by multiplying. That's the same thing as x to the 20th. Right? Because this means x to the 5th times x to the 5th times x to the 5th times x to the 5th. That's what that means. Which is x to the 20th. So here, that's already been multiplied, right? So I'm going to be going from here to here. And I skipped a step. We could multiply these, right? That was 5 times 4, which was x to the 20th. So we're kind of at this step. And we're going to go back to this step. Right? Because I've got two things being multiplied. So now I need to go back to that. So here's how we'll do that. How could we rewrite the squiggly equal signs. I could write that as 8 raised to the...
X raised to the 1/3.
That's one option. Is that the only way we could do it?
No, 8 times 3.
It's not 8 times 3. We could also do 8 raised to the...
X minus 3.
No. Please listen to like when I'm leading up to teaching this, when you guys were not paying any attention to me, and now you're just blurting stuff out. This is 8 raised to the 1/3 raised to the x. I could choose either one of these. They're both equivalent. It's like this could also be x to the 4th to the 5th.
Which could also be to the 20th.
It's still x to the 20th. Either way, right? I didn't know which one it was. I can choose. Which one of these is going to be more beneficial? Do we know what 8 to the x is?
No.
Not really. Do we know what 8 to the 1/3 is?
Yes.
We can find that. What is 8 to the 1/3? No calculator.
3.
It's not 3.
4.
8
Do you guys know what fraction exponents mean?
It's, you divide.
You do not divide. What is 16? You take the square root when it's a 1/2.
You take the cube root.
That's correct. Because it's to the 1/3, we would take the cube root of 8,
Which is 2.
which is 2. So the cube root of 8 is 2, which means 8 to the 1/3 is the same thing as 2
2.
raised to the x. So which of these was 2 raised to the x?
Money knows.
But it would be the.
It was none of these, is it?
Uh-huh. The one right above the and symbol.
Correct. It's from our first group of 6. So the squig. Now, can you guys try sigma? You'll see if you can figure out which one it matches with.
Okay, so sigma. I actually can't.
Okay, I know what I'm going to try to do.
You can raise it.
I know what I'm going to try to do.
It's 4 to the x.
It's not 4.
It's not 4.
It's not 2. How could I rewrite this? It's not 1/8. You guys are on the right track, but you're getting the wrong numbers.
I got 6.
How could I rewrite it first?
Okay, 16 to the negative 2 to the x.
16 to the negative second to the x. I agree with that.
Wouldn't 16 to the negative second be 4? Because you got that.
It's not 4. When I have a negative exponent, what do I have to do? This was not a negative exponent.
You gotta flip it.
Yes.
Oh.
Negative exponent means you have to flip this. So this would be the same thing as 1 over 16 to the second to the x. And 1 over 16 to the second is 1 over 256
Oh,
to the x.
sigma.
But that wasn't one of the options, right? You follow my logic. That wasn't one of them. So I was going to try a different strategy, something different. So here's how you try to rewrite these. So again, all these things we're learning, we are learning ways to simplify exponential expressions. This is very important, what we're learning. Here's what I think. Because this doesn't match any of them before, this is right, but remember, it can take several different forms. So I'm going to have to write it a different way. So my first thought is, and I don't know if this is going to work, I'm going to go back to my original base, and can I write this base as a power? So like 16, can I write it as some base raised to some exponent? What?
4 to 2.
It could be 4 to the second. It could also be 2 to the 4th. I don't know which one's going to work, but I'm going to try both of them. Okay? So let me start with. Let me go to a new slide because this is a mess over here. So I've got 16 raised to the negative 2x. I'm going to start with writing it as 2 to the 4th. I don't know which one's right. I'm just picking that one first because it's the simpler base. So 16 is the same thing as 2 to the 4th. And this has to be raised to the negative 2x.
We don't do it 3 high, where we go to negative 2 to the 4th to the negative 2nd, then do that.
We could, but that just looks, I mean, that look really.
That's a little
That's
staircase.
like, what's a sigma? What are you doing here?
Okay, so I just don't know if I'm gonna make that match one of these. Let's try what you're saying. You said 2 to the 4th to the negative 2nd to the x. And then here, this is a power to a power, so we could multiply. So this is 2 to the negative 8 to the x, which is 1 over 2 to the 8th to the x, which is going to be that same number, right? 1 over 2 to the 8th is 1 over 256, which is not, that's still not being helpful. So let me try the other way. If I write this as 4 to the 2nd to the negative 2x. And this could be 4 to the negative 4x, which would be 1 over 4 to the 4th to the x.
Oh, that's it. Because if you.
Could we just take out the 4 and make it a percent symbol?
Do we have this anywhere? Do we have a 1/4 somewhere? We have a 1/4 to the x.
We have a 1/2 to the x, so.
Yeah, that is true.
But doesn't that just equal to 1 over 256 to the x then? That same problem?
Maybe we just divide.
4 times 4 is 16.
So we get 2 and half x.
64.
I don't think it matches any of these.
Yeah, me neither. There's probably just the next one.
Negative 2.
Yeah,
It does. I mean, it doesn't match any of these.
this
so-
sigma is not very sigma.
But all of these skills that I just practiced here, those are important. Okay? So hopefully we kind of understand what's going on there. I don't think sigma matches.
I swear.
What page is that on?
I'm on page 18. So now we're going to treat this like we did when we did transformations of graphs. Right? So if you look at this, what do you think the parent function would be? 2 to the x. So what's different here is the parent function is always going to be some number raised to the x. It's not always 2 though. It could be 3 to the x, 4 to the x, 1/2 to the x. Okay? Those are going to be your parent functions. So now, what's happening to 2 to the x? Well, we've got this plus 1. Would you guys say this is inside or outside of the function?
Inside.
Inside affects the x's, and inside does the opposite from what it looks like it's going to do. So a plus 1 on the inside affecting the x's is going to shift the graph Left 1. The plus 6, is this inside or outside?
Outside.
Outside affects the y. So the plus 6 is going to move the graph
Up 6.
up 6. So this graph, 2 to the x, what transformations occurred? We went left 1 and up 6. So let's graph what 2 to the x looks like first, and then let's transform it. So what would 2 to the x look like? If I plugged in 0 for x, I would get 1. So plugging in 0 for x, I get 1. What if I plugged in 1 for x? I would get
You get
2.
2.
If I plugged in 2 for x, I would get 4. What if I plugged in negative 1 for x? What's 2 to the negative first? 1/2. And if I plugged in negative 2, I would get 1/4. 2 to the negative second is the same. Yeah, the next one would be 1/8. But I didn't ask that one. 2 to the negative second would be 1/2 to the second, which would be 1/4, right? And so I've got a general idea for what 2 to the x looks like. Right? This is 2 to the x. Now, how would I move this graph left 1 and up 6? Well, I'm just going to take this point here, and I'm going to move it left 1. I'm going to take the point that's at 1, 2 and move it left 1. Take the point that's at 2, 4, move it left 1. Is everybody okay with that? I just took those 5 points, moved them left 1. Now I need to move them all up 6. So that's going to be hard on my graph. I should have done a better job. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now if I go up 6, 1, 2, 3, 4, 5, 6. Up 6, 1, 2, 3, 4, 5, 6. Up 6, 1, 2, 3, 4, 5, 6. Up 6, this is at the halfway point. So that's 1, 2, 3, 4, 5, 6. And then up 6. And so the orange would be the correct graph. You see how I went from the blue? The blue is my original. That's a lie, isn't it? The red was my original. And then I shifted that left 1. And then I went up 6. Now, when you look at the blue, do you see that as moving left 1? It kind of looks like left 1, but it also kind of looks like up 1 for here, right? So it can get kind of trippy when you look at these. If you just look at the points, did I move left? Did I move up? It can be a little confusing. Just know that if you think you've moved up 1 works here, but up 1 does not work here, right?
Or
So-
an asymptote. Does not work.
Correct. Or the asymptote didn't change. I got you. That's a good way to spot it. All right, what's the domain? What's the list of all possible x values for my orange? Right, this is my final graph.
Negative infinity, infinity.
So the domain is all real numbers. Remember, what are the 2 things that can cause a problem with the domain? There's only 2 things. 2 things you're not allowed to do in math. Negative under a square root. Divide by 0. When you look at my equation, does it have a fraction?
Yes. Oh, wait.
This has a fraction?
No, I'll see the graph.
Is there some way I could divide by 0 here?
No.
No. Is there some way I could take the square root of a negative here?
No.
So that's why it's all real numbers, right? And we can see it graphically. We could plug in anything. What about the range? What's the lowest y value the graph takes on? Is the orange going to continue to... Is it going to decrease forever as I go left? Yes. But is it going to reach a
Yes.
value that's never going to go beneath?
6.
Yes. 6. Because remember, there's a horizontal asymptote here originally. Right? It never goes beneath that originally. But now then that got moved up 6 with the rest of my graphs. So the lowest y value the graph takes on is 6. Does it actually ever touch 6? No.
Does this say Ross?
It says R,
See.
colon, parenthesis, 6, comma. What's the highest y value the graph takes on? The range is from 6 to infinity. What's my y-intercept? Where did it cross the y-axis here? So I could count 1, 2, 3, 4, 5, 6, 7, 8. What's another way you could find the y-intercept?
Plug 0 for X.
Plug 0 for x. We'll do it. What's 0 plus 1?
0.
It's not 0. 0 plus 1. 1. What is 2 to the first? Oh my gosh. 2. What is 2 plus 6? 8. You might want to set the mental math out. This may not be your thing.
No, it is mine.
Okay. It didn't sound too good. You thought 0 plus 1 was 0. I would have killed you in travel. Did y'all play travel in elementary school?
What is that?
Where you held up flashcards and you had to go around the room. You played somebody head to head, one on one.
No, it is not.
No, well, I used to dominate.
Yeah, we played it in the Rose class.
And my brothers, we played travel. And
Basketball.
in
Tennis ball.
my first grade class, I had Miss Martin. Miss Martin, I dominated so bad at travel. After I went around the room once, she would make me sit in the corner. I couldn't play anymore. So she wouldn't let me keep playing. But she'd also let me sit at her desk sometimes. I'd get to get a sticker. So I thought it was like the big reward. I didn't know she just wanted other kids to have success, and she didn't want me to do all the practice because I didn't need it. So it made sense. But it was fair. She's a great teacher. Sketch the graph. We just sketched the graph, right? So I've done that. What's the limit as x approaches negative infinity? So as the x's get really, really small, what are the y's doing?
Getting really, really big.
They are not getting really, really big. Go into 6.
Oh, I thought you were talking about the other way. As the X gets
That's
big.
why I said when the x's get small. The other one, when the x's get really big, what are the y's doing? Getting big. How big?
Really big.
Go into infinity.
Infinity big.
Look at number 2. An exponential function of the form a to the x plus c is shown. Which of the following statements is not guaranteed? You can't say for certainty that it's true. So I see that limit statement. I want to look at that first. Okay? This says the limit as x gets really big of f of x is c.
No.
So what's happening is the x's get really big.
There's an asymptote.
Yeah, there's an asymptote here.
An asymptote cannot equal something. It gets really close.
That doesn't... The limit does. That's what it approaches. That's a bad answer.
But that's a negative.
So this is negative. I do agree. This is negative. But where's the horizontal asymptote normally?
0.
It's normally at the x-axis. So that has got shifted down some. What's the only way we can shift this graph down?
If C is negative.
If c was negative. C can be negative, even though it doesn't have a negative symbol here. C could be any number, so it's going to be some negative number. And this moved it down to that value. So D is correct, right? D is correct. So I've eliminated D. D is correct, which makes it not guaranteed. That's confusing. Okay? Let's look at some of the other ones. Let's look at A. I like A. That one looks simple.
C is greater than 0.
That does not say greater than. Oh my gosh. I mean, this is so.
Okay, I knew that one.
This is just awful. C is less than 0. What would that mean? C would have to be negative. Did
Which
we
it is.
agree C was negative?
I was looking at
We
the
just said
last
that, so
part
it's
of
not
B.
A.
I was looking at the last part of B.
Right. I really don't want to deal with B. B breaks my head, so I'm going to C next. What does C tell me? It says the A value must be between 0 and 1.
Which is true,
Why is that true?
because it's decreasing.
Because it's decay, right? Because this is a decay problem, the A value must be less than 1. But it can't be negative, so it has to also be greater than 0.
Which means it's B.
No. You're right, it does mean it's B. Because I'm getting confused again. C is also correct, so it's eliminated. So B, A plus C must be 0. Must be greater than 0. Well, we said C was something negative, right?
What?
So we don't know what it is, but let's pretend like it's -1 is C. And what did we say A was? We said A was between,
What's a fraction?
yeah, so let's try 1/2. So what would be 1/2 minus 1? It would be -1. Is -1 greater than 0? No. So that's
So-
not guaranteed.
I think C is probably like negative 0.000001.
Okay, I don't really know where we're even going with this. Okay, I'm not going to entertain that. 3. The equation for graph G in the card sort was 2 to the x minus 1. Write an alternate equation for G that uses a vertical dilation instead of a horizontal shift. So how did we get vertical dilations? We needed something. Vertical is the y's. So I need to affect the y's. Y's is done on the outside. And to dilate means I need to multiply. So can I write this where I multiply by something on the outside?
1/2 times 2 to the x.
You mean we've already done this?
Yes.
We just didn't have the wording, right?
We literally did all this. That's how I noticed it.
2 raised to the x minus 1 is the same thing as 2 to the x times 2 to the negative first. And what was 2 to the negative first?
1/2
1/2.
times 2 to the x.
So now then, you see how before, if I look at this, this is a shift right 1. Right? On the inside, subtracted is the opposite. So shifting the graph right 1 is the same thing as multiplying all of the y values by 1/2. They have the exact same result, which is crazy, but they are the same graph. Okay? And 4, write an equation for an exponential function that is increasing and concave down over its entire domain. So what needs to happen for it to be increasing? From left to right, the y's must go up. What has to happen for it to be concave down? It must be shaped like
A upside
that,
down bowl.
right? Is this increasing?
No.
It is increasing. Is it concave down?
Yeah.
It is. So I need something that looks like this. So can you write an equation for me that looks like that?
Wait,
So is this...
that's increasing at a decreasing rate.
Oh, gosh. That's not what we needed. It's decay. That's a decay problem because it's getting closer and closer to 0. So what needs to happen to my rate to make it a decay problem?
Has to be a fraction. Or it's got to be less than 1. But
Okay? So what would 1/2 to the x look like on its own? If I just wrote this as my answer.
Like this.
1/2 to the x would look like this.
So there's going to be a negative 1/2.
this rate can never be negative. So what has to happen to go from here to here? I need a,
Or vertical dilation.
not dilation, but a reflection over the x-axis. That changes the sign of the y. So how could I reflect this?
Put a negative outside of the parentheses.
That's it.
Boom.
So this would work? Is this the only correct answer? No. So like you could have like -3 times 1/2 x. That would be correct. I just need a negative number on the outside and I need something less than 1 on the inside. Okay, those are the things. Look at this one. Look at number 1 here. Look at the exponential function. Question A, what is the initial value? So I've not used that terminology. Initial value is another way to say y-intercept. How do you find the initial value or the y-intercept? Plug in 0 for x. So what is 5 to the 0? 1. What's 1 times 1/2? So how do we always find our initial value? Well, as long as your exponent is only an x, then the a value is always your initial value. Okay?
I thought the A value here was 5.
That's the b value. What's the base?
1/2.
It's not 1/2.
5. Because that's B.
Base is the base of your exponent. The b value is the base. So remember, these are in the form of a times b to the x. A is the initial value, b is the base. C, find f of 3. I don't care about the second part of that question. I don't even know what that's asking. What is f of 3? So you would have to do 5 raised to the third, which is 125. 125 times 1/2?
125 times 1/2 is 74.
Why don't I just write it as 125 over 2?
62.5.
It's not right. Why don't I write it as 125 over... Oh, that is right. It is 62.5. I would just write it like this. Save myself the mental math. 125 times 1/2 is 125 over 2.
125 half.
Is this exponential growth or exponential decay?
This is probably
Growth.
Growth.
How do you know?
Because it's more than 1.
Because the a value is positive and the b value is bigger than 1. Exponential growth. Look at 2. How could I rewrite b to the x times b to the 4th with a single base? So single base means I only want 1 power.
B to the x to the 4x.
B to the x plus 4.
B to the x.
So what do? We've got a power times a power. Do they have the same base? We keep the base the same. What do we do with the exponents? Add them. When you multiply powers, you keep the base the same, you add the exponents. Next, can you write b to the -6th with a positive exponent? How do you get rid of a negative exponent?
You make B fraction.
You rewrite the base. This is b over 1. I could write that as 1 over b raised to the 6th. So b to the -6th is the same thing as 1 over b to the 6th. All these rules are super important, guys. Like, we're fixing to do them like crazy when we get into logarithms. If you don't remember them now, it's going to just snowball. Okay, it gets really out of hand really fast. So make sure you understand what we're doing here. Can you write b to the 1/4 as a root of b? So what was 16 to the 1/2?
16.
256 over
No.
156.
No. You're doing 16 to the -2nd. You guys are going to have to get these straight, which one is which. 16 to the -2nd is 1 over 16 to the 2nd, which is 1 over 256.
16 to the 1/2 is 4.
That's correct. 16 to the 1/2 is 4, because how can I write fractions as exponents?
Square root.
So B
You can write a square root because it's got a 2 in the denominator. So what would b to the 1/4 be?
B times 4.
It's not b times 4. It's not a square root, it's a fourth root. This would be the fourth root of b. The fourth root of b. We have square roots, cubic roots, and after that it's just fourth root, fifth root, sixth root. Okay, looking here at number 3, we're just really having to tell what are the two limits. So we want to know the limit as x goes to negative infinity, which is here, and the limit as x goes to positive infinity, which is here. So when I look at question 1, the a value is positive. So the a value being positive lets me know that it's on the top half. So I've either got an exponential growth problem or an exponential decay problem because the a value is positive. The b value being more than 1 lets me know it is an exponential growth problem. So my graph would look like the red graph here. So if that's my graph, what's the limit as x goes to negative infinity? What are the y's doing? Getting closer to 0. So which choice is that? That is choice A. It's choice A. As x goes to negative infinity. And what about as x goes to positive infinity? The y's go towards infinity. So that one would be F. So A and F for number 1. 2, the A is positive, so I know it's either one of these graphs again. But now the B value is less than 1, so it's going to be the blue one here, the decay problem. So what's going to happen as x goes to negative infinity? Y's go to infinity, which would be E. And then what about as x goes to positive infinity? 0. So E and B. 3, the A value is negative. So I know I have a graph that does either this or this. Now then the B value being, this is awful, I know. The B value being greater than 5, being greater than 1, means it is a growth problem. So that one would be, this one here. So what's happening as x goes to negative infinity? Y's go towards 0, so that should be A. And then as x goes to positive infinity, y's go towards negative infinity. This would be A and D. See if you guys can do 4.
Is there minions out there?
At Universal. Not at Epic Universe. They have a whole Minions land at Universal.
Yeah, I need to go there.
Huh?
I like the minions.
Minions guy? Universal has the Minions. It has Jimmy Fallon. It has, Race Through New York starring Jimmy Fallon. It has Revenge of the Mummy, Transformers. It has Diagon Alley, Men in Black, Alien Attack, The Simpsons.
What about Harry Potter? I feel like I've seen
Diagon Alley is on that side. Harry Potter's going to be in all three parks. It's in Universal Studios. They have Diagon Alley, which is where you go to buy all your stuff, and then they have the Green Gots Bank, so you can go ride a ride, escaping from Green Gots. Then in Islands of Adventure, they have Hogwarts and Hogsmeade Village.
What's the best Harry Potter like? Universal or the Island?
That's a tricky question.
I know you're a Harry Potter guy.
Islands of Adventure has the better ride. Hagrid's Motorbike Adventure is the best ride. And the second best ride is over there too. The one in the castle, Forbidden Journey. But Diagon Alley is so immersive. It's so perfect.
What's the best ride I've ever seen in parks?
It's either Velocicoaster or Hagrid's Motorbike Adventure.
Wait, do you get on like a motorcycle?
Mm-hmm.
Yeah.
It's a motorcycle and a sidecar.
I've never been to Universal. I went to Disney World and I was like, that's big.
I remember that.
Overrated. Yeah, a little overrated. What did we get here? Did we get our answer, or are we confused?
Yes.
What did we get?
16, 8, 4, 2, 1.
That's correct. 16, 8, 4, 2, and 1. How did you get that?
-4.
That's correct. We know h of x is whatever f of x was plus 4. So all these have had 4 added to them. So to get back to f of x, we just subtract 4. Now, how do we know that f of x is exponential? You can divide this value by this value, right? 16 divided by 8 gives 2. What is 8 divided by 4? 4 over 2. 2 over 1. That's how you know. Okay.
I didn't do it by that. I did it by the h of x.
Okay, but the h of x one's not f of x. But yeah, with h of x, you'd have to do the first difference and then start your division. Yep. I just don't know if they would count that because you're showing h of x versus f of x, and this one's asking for f of x. Mm-hmm.
Which means it was linear if there's a first difference.
If the first difference was constant. Oh, please don't be sold out. 5. The graph of f is a horizontal dilation of the graph of g of x equals 2 to the x. Horizontal is this direction, right? The x's. The horizontal dilation is here. We're multiplying on the inside by 3. Show that f has an equivalent form with a change of the base. So they want us to take 2 raised to the 3x and change its form to look like something else. Okay? What can we do here?
2 to the third times 2 to the x.
This is incorrect. What would this simplify to be?
2 to the third to the x.
This would be 3 plus x. But it shouldn't be 3 plus x. It should be 3 times x.
It's 2 to the third to the x.
That's correct. We could write this as 2 to the third to the x. When we're multiplying the powers, we have to go power to a power. When the powers are being added, when the exponent's being added, then that's when you can do what you did. So we've got to get all that straightened out. All right? It's going to be very important. Now, what is 2 to the third? 2 times 2, 4 times 2. So 2 to the 3x is the same thing as 8 to the x. Let's make sure that works. What if we plugged in 0 to this? What is 8 to the 0 power? Good. What if we plugged in 1 to this? 8 to the first power is? You see how both those points are on this as well? Try this one.
So I'm glad we won.
At 5:30.
It opened at 5, but I didn't check till 5:30. If I'd have been on at 5, I could have been done. But I was 30. All right, you finished with 6? So the original graph is 2 raised to the x plus 3. Sam says this could be a vertical translation. Verticals is the y's. So we affect the y's by doing something on the outside. This is currently a horizontal translation. Right? So can we change this to have something to do with the y's?
Yes.
Well, 2 to the x plus 3 could be written as
2 to the x plus 2 to the third. Or times 2 to the third.
2 to the x times 2 to the third.
Can be written as 2 to the x times 8.
2 to the x times 8. So this is a vertical transformation. Is this a vertical translation? No, this is what? This is a vertical stretch, or the fancy word they would use is a, but you're correct. It's not a translation. Translation is a shift, left, right, up, or down. This is a stretch. So is Sam correct? Nah. And then you could say it could be a vertical dilation, stretch of 8. I wish I could get on Facebook and read what everybody's saying in the pass holder page. Now, which one? So like the 2? What goes there? 1? What do you guys think? You think that's 1? I agree. I think it's 1.
So then, yeah, I think I'm on the right track.
Okay.
And the second one is going to be a 2.
Is this one going to be a 2? But this one was already a 2.
Is it 1/2?
Huh?
1/2?
1/2?
Yeah.
Negative.
1/2's over here.
Negative 1/2.
It's not going to be negative 1/2. I'm not surprised you guys aren't getting this one.
1/4.
It's not 1/4. Skip around. You don't have to do them in order. You might could find a different one you know.
Is the score,
Because if 1/2 say is 1, then 1/4 would be 1/2.
is 0, 0?
It's not good logic.
So I would actually be here.
Is 0 0? It's not.
Is it, you think that's right? It's what? Yeah.
77.
Yeah, it's just not.
Their defense is kind of
If we're skipping around, could 1/4 be -2?
They would score.
1/4 is -2. It is.
And then 1/8 is -3.
It is.
Okay. I haven't got anywhere from that. I'm on to something.
You're on to something, Colin. I'll see it.
The 0, 0.
0's not 0.
Oh,
It's 0 2. Wait. Oh.
It's 0 2. It's not.
Wait. 64.
64 is 6.
Is 1 0?
Is 1 0? It is. So what are we seeing here? What pattern are we seeing?
good question.
If you had to write a rule, try to write an equation. How are you getting anybody got a rule? So like for example, just so you guys know what we're talking about here. And so if this was what was happening, the rule here is right 3x plus 2. Because we're changing by 3 every time. So the slope is 3. It's a common difference. And then the y-intercept here is 2. Right, so that would be that rule. Another one. Yeah, I agree. That's what I'm trying to see if you guys can come up with a rule.
If there's a fraction, it's negative.
Like this one is x squared.
Is 3, 2?
Is 3 2? Is not.
So,
I'll tell you this, I would quit trying to figure out these other values, and I would try to write the rule.
when you're going from 1 to 0 and then 2 to 1, that's going upward. So why wouldn't 3 be 2?
Because 4 was 2.
And then it wouldn't be a function.
It could be. It wouldn't be 1-to-1 function.
Yeah, it'd be a
So
substitute.
3 is 1.5.
3 is 1.5? Not quite.
But it's a decimal. It's one decimal.
1 point.
Question.
So you're going up 1/2 x plus 1 is our rule.
Okay, let's plug one in and see. Let's plug in 5. So I plug in 5 for 32. 1/2 times 32 is 16. 16 plus 1 is 17.
Alright, so I have a feeling this function's giving me brain issues.
It is.
Alright. Cube root is
What about the square root? What's the square root of 2?
square root of 32.
Is there a square root of 2? No. So square root of 32?
Square root of 32?
Do you know this one? Like, do you know that?
Yeah.
I figured, but I was just making sure. Because like,
This was
our
very-
classes can close.
So You know, we normally write our rules like this. I'll tell you this. We normally write y equals something with an x.
Yeah, this one's gonna be x equals something with a y.
I agree. X equals something with a y.
Oh, how'd you come up with that?
So pretend like you plugged in the y's.
Oh.
X equals y. I can make a very long piecewise function for this.
So, all right, let's look at this. Let's list them with y's and then x's. So, when we plugged in -3, we got 8. When we plugged in -2, when we plugged in -3, we got 1/8. When we plugged in -2, we got 1/4. When we plugged in 0, we got 1. When we plugged in 1, we got 2. When we plugged in 2, we got 4. When we plugged in 3, we did. 3 is 8. 4 is 16. 5 is 32. 6 is 64. Is that bad? No one? It's going to be exponential. What's happening each time as I go from 2 to 4? Doubling, and then what? Doubling, and then what? So what's my common rate? What'd you say? 2 to the y.
Wait, when is that parts open?
May 24th.
Oh. And you have to buy a ticket now?
Yeah, they're sold out on the 24th already. I'm sorry, 22nd is when it opens. Today's the 24th. I got mismatched. I'm wanting to go May 27th is my goal.
You're gonna try today to the May 27th.
I'm going to try today to get May 27th as my day I'm going to go. It's not looking good. The longer this goes, the more people that are getting tickets, and I isn't getting the ticket. So, what outputs were we not able to find? Well, we couldn't figure out 0, right? So, think about it. What did I have to plug in? 2 raised to what power gives me 0? 2 raised to what is 0?
1.
No.
Wait, if the x is 30 and g, you gotta square root. You gotta square root it.
You don't square root it.
Why? If you raise 2 to the 0th power, it's probably equal.
And we're
No. No.
To the negative
No, no.
1.
When it was x to the second, to get x by itself, we square rooted. Because the squared and the squared cancel. Now then, you've got x is stuck up here.
yeah, basically what happens is so I don't know.
That's what I'm telling you. We've got to learn new math to be able to get the x by itself. Because I can do it when it's down here and there's an exponent. But I've never done it when it is the exponent.
Radical x.
Right. So that technically will eliminate these, and you'll be left with radical 2. I'm sorry, not radical 2. You'll just be left with 2. Right, the x root of 2 to the x would cancel, and you'd be left with 2. But now the other side is going to be y stuck inside of x root. Yeah, not great. Right, so I can't do that. It's not going to fix it.
You could probably just like, wait, you could just turn the page.
We're not trying to solve yet. I'm just asking you, 2 raised to what power is 0?
One.
What's 2 to the first?
One.
2 to the first. Oh my gosh. 2 to the first is 2. 2 to the 0 is 1. And then how am I getting closer to 0? Yeah, because then I plugged in -1 and I get a half. -2 gets me a 4. -3 gets me 1/8. -4 would be 1/16. -5 is 1/32. So this graph, what's this graph going to look like?
A decay.
It's an asymptote. It never touches.
Thank
0.
you. Yes, thank you. Thank you. So what do I have to raise 2 to get to 0?
Infinity. You can't.
I can't do it. Because there is a horizontal asymptote at 0. Doesn't get there.
And it
What do I have to
can't.
raise it to get to -1?
You can't.
Can't. What do I have to raise it to get to 3? 2 raised to what power is 3?
You can't.
It's like probably like 1 point.
Yeah, exactly. It's still not a pretty number, right? I still don't know for sure. So,
1 point. Question mark. Question mark. Question mark. Question mark. 2 raised to what is 64?
next.
Like
Perinovan believes 24, 4.585 is a point on the graph. Is he correct? Should this point be on the graph?
2 to the 4.5.
2 raised to the 4.585. Exactly. So 2 to the 4.585 gives you what?
Not 24.
What is it? I don't know. Plug it in.
4.00062.
Never
I would
mind.
say yes, it should.
So is he correct?
Yes.
Kind of. Because we're rounding to 3 decimal places, it should be 24.001. So I would say close,
We're not going to get to them.
but I wouldn't say that's exactly correct. No, I wouldn't. How are the outputs x equals 8 and x equals 1/8 related? So when x was 8, the y value was 3. When x was 1/8, the y value was -3. Why does this happen? Because -3 gives me a negative exponent, right? What happens when you have a negative exponent? It goes to the denominator. So negative exponents.
What does that say? They are opposite sign.
Mm-hmm.
What's the bottom sign?
They're opposite signed, and then I put a period. Then I said negative exponents are reciprocals of the b value because this is b to the x, right? So I'm just calling it the b value.
Permanent. Or reciprocals to B values.
All right. Pagel thinks 3 is the output. The y is 1.5. That sounds like Colin. Can we give a convincing argument otherwise? So this is 2 raised to the 1.5. I want to know, does that equal 3? So let's try to rewrite this. Do you know what 2 to the 1.5 is? You can use your calculator. Let's try to do it without a calculator. Do you know what 2 to the 1.5 is on your own? I don't. I don't have a clue. I don't know what it is. So if you know, you guys are stupid geniuses. Okay, I don't have any idea. 1.5 is the same thing as 3/2. So what can I do when I have a fraction exponent? We talked about it yesterday.
You can take the flip it.
No. That's negative. Again, you're going to have to get these rules straight. You say the wrong one every time. Negative is flip it. Fraction is not flip it. Fraction is, this is a square root raised to the third power. The denominator is the root. The numerator is what we're raising the power to. So this is the square root of 2 to the third. What is 2 to the third? It's 8. What's the square root of 8?
2.
We don't know. Some decimal. It's a sussy decimal.
I'll tell you what it isn't. It isn't 3. Right? And that's what they said it's supposed to be. They said it should get 3. But I got the square root of 8. That's not 3. The square root of 9 would give me 3. So, this is my argument that they are incorrect. I'm never gonna ticket. This is awful. This is so sad. Okay, Farrah wants to know what power she can raise 4 to get 64. So she writes 4 raised to what equals 64? How is this similar or different to our mystery function?
Oh no.
Well, this is similar because I have an unknown in the exponent. How is this different than our mystery function? Okay, it's different. Thank you. The base is 4, not 2. So do we have a strategy for figuring out what the question mark is? I know what you guys are going to say. I know what you're going to say. I'm not going to like your strategy. Go ahead. What's your strategy? Yep, there you go. That's not what we're looking for. I can just try some stuff, okay? That's not bad.
I like that.
That's not bad.
If you're in a
I don't like it.
spot,
So watch this. Here's another strategy for you. Can I write 64 as a power of 4?
Yes.
64 is what?
It's 8 times 8.
It's 4 to the third.
So 8 times 8 would be 16 times.
So this means what? If 4 raised to something is equal to 4 to the third, then what do I know?
64 is also equal.
The question mark is 3. Right?
What? Oh, yeah.
4 raised to something is the same thing as 4 to the third. What's the something? 3. Yeah. Okay. I had to make it. My wait time is 54 minutes. I'm under an hour. Let's go. Let's see if anybody else in my family's texted. Not yet.
Are they all on there?
Yes, we're all at different places. My dad is slightly ahead of me. My youngest brother, he is way ahead of me in line. And